Okay, so in this particular question here, you are asked to find the probability of B. All right. So since you do not know whether it is mutually exclusive or independent, so we cannot assume this to be as what was mentioned. Hence, looking at the laws of probability, we can only choose from either of the general laws, which you can see at the right side. So every time you encounter probability related questions, you have to know whether to use the general, although the general law can be applied to all, or whether to use the laws under mutually exclusive, the laws under independent, or the laws under complementary. Again, there is no mention, so we can only use the general laws. So before you start solving this one, you have to identify and analyze first what is being asked. So here we are asked to find the probability of B, and these are the given. So if you try to look at in the formula or in the laws, we can find the probability of B either by using the first law, all right? So if we do the first law, we need to have the other given. Unfortunately, we don't have the probability of A intersection B. All right. Likewise, if we use the second formula, still we need the probability of A intersection B. And since we have no other choice here to find the probability of A intersection B, what we can do instead is to substitute the given to the two laws, and here by doing so we can come up with two different equations. All right, so we can have our equation 1 using the first law. So we now have here the probability of A union B, which in this case is 0.75, equal to the probability of A, which is 0.35, plus the probability of B, which is a known. All right, and we have minus the probability of A intersection B. Now we also have our equation 2, but before we proceed to equation 2, let's try to simplify this first. So we can have here 0.40 equal to the probability of B minus the probability of A intersection B. Now our equation 2, we can form this one by using the second law. So we have the probability of A given B, which in this case is 0.35, equal to the probability of A intersection B over the probability of B, by which we can remove, or we can modify this so that we don't see any rational expression. We can have 0.35 probability times probability of B is equal to the probability of A intersection B. So if you try to look at it, we have two equations here, equation 1 and equation number 2. And if you recall a lesson in mathematics, this is actually simultaneous equations. Okay, equations in linear equations in two variables. So we can take a look at this as our x. If you try to put it in that particular lesson, this could be our x, this could be our y, this could be our x, this could be our y. All right. So it's like 0.40 is equal to x minus y, and the other one is 0.35x is equal to y. Okay. Now, putting in mind that we wanted to solve our probability of B, therefore, when we apply the methods of solving simultaneous equations, we have to make sure that the probability of B, this variable, should not be eliminated, should remain as is. In other words, what we have to remove or eliminate here is the probability, the variable, which is the probability of A intersection B. It's either we use the substitution method or we use the elimination method. So in this case, it's easy to use the substitution method because we already know from equation 2 that the probability of A intersection B is just equal to this expression, 0.35 probability of B. So what we can do is we can just go ahead and substitute this to the first equation. Okay, so if we substitute the second equation to the first equation, so we can have 0.40 equal to the probability of B minus. So this is where we now substitute this, this one, to the value here of supposed to be the probability of A intersection B. So substituting it, we now have 0.35 probability of B. Alright, now to continue, we now have 0.40 equal to probability of B minus 0.35 probability of B. So if we combine like terms, this would now be 0.65 probability of B, and hence dividing both sides by 0.65, 0.65. So the probability of B would now be equal to, if you are to use your calculators here, it would be a lot easier for you to do it. So allow me to use my calculator first. So that's 0.4 divided by 0.65. So this actually gives us 8/13. All right. Let me just double check if I am correct. If your answer is in decimal, try to convert it to a fraction as much as possible. If you are not told to round it off to a certain number of decimals, better write it as a fraction so that you can capture the entire value and you don't have to remove the others. Indeed, it is 8/13. Okay, so this is how we were able to find the probability of B. So this is what I'm telling you about. So since we did not eliminate the probability of B from equation 2, when we do our solving by means of substitution or elimination, automatically we can get the value of what we are looking for, the value of the unknown. If we had it the other way around, if we eliminated the probability of B, what happens here is we can get first the answer to the probability of A union B, which after that we need to still substitute in order to solve what we are really looking for. So it's all up to you.